In this example, we're going to graph a polar equation by hand. So if we're looking at this one, you're thinking about those formats from the first video from this section. This looks like it's going to fit the format of a lemicon. So what we want to do is we want to pick some theta values to plug in. So we've got theta and we're going to have r. I'm going to start with 0. If I plug 0 in, I know cosine of 0 is 1. So my r value is going to be 1 minus 3, which is a negative 2. And then let's try plugging in pi over 4. So we're going to have 1 minus 3 times cosine of pi over 4, which is square root of 2 over 2. And that's going to be about, and I'm going to use my calculator to get a decimal, negative 1.12. Then we're going to use pi over 2. So you want to use nice values if you can to try to give you some nice values. If I plug pi over 2 in, we know cosine pi over 2 is 0, so I'm just going to get a 1. And then I've got 3 pi over 4. When I plug 3 pi over 4 in, that's negative square root of 2 over 2. And I need a decimal approximation for that. So 3.12. Plug in pi. We're going to have 1 minus 3 times negative 1, which is going to give me 4. 5 pi over 4. 1 minus 3 times negative square root of 2 over 2. So it's going to be about 3.12. 7 pi over 4. At negative 1.12 again. And then at 2 pi, I'm going to have 1 minus 3 times 1, which is a negative 2. So you want to pick theta values that's going to give you a full revolution of what's going on so you can get the full graph. For this one, we need to go from 0 to 2 pi. So we've got all these points. Now we're going to graph them. So at 0, we're over here at negative 2. At pi over 4, which is going to be right around here, we're going to be at negative 1.12. So since my r value is negative, I'm going to go along the opposite side of that terminal side. So somewhere around here. So I'll go this direction. At pi over 2, we're at 1. At 3 pi over 4, which would be along here, we're at 3.12. At pi, we're at 4. At 5 pi over 4, which would be along here, we're at 3.12. So we're moving along that terminal side. At 7 pi over 4, let's do 3 pi over 2. I left that one out. 3 pi over 2. So we're going to have 1 minus 3 times cosine of 3 pi over 2. And that would put me at 1. So at 3 pi over 2, we're going to be at 1. And then at 7 pi over 4, we're going to be at negative 1.12. So we're going to move along that terminal side, or the opposite side of the terminal side. And then at 2 pi, which is here, we're going to be at negative 2, which would be back here. So you can see how it's forming this graph. We started here, and then we just went around. Now, if we compare that to what Desmos looks like, here's our graph in Desmos, you're going to see the same thing. And that inner loop's quite big on this one. So it's really just about figuring out where my points are going to be, and connecting those dots is easier, I think, to connect the dots as you go.